Alrighty students, today we're going to be doing our first video on our notes sheet. So before we get started, I want to make sure you do have your note sheets out. Chemistry students, your note sheet for this unit does look like this. So we're going to be looking right here at Bohr diagrams and Lewis structures. Okay, so back to our PowerPoint here, if I present that. You should have learned what a Lewis structure and Bohr diagram were in your last activity, that chem quest that you did, but we are going to go over some concrete notes now to make sure you understood that correctly. Okay, maybe if it comes up. There we go. A Bohr diagram. A Bohr diagram includes all the electrons for an element. Okay, so a Bohr diagram can also be called an orbital diagram. It's the same thing. You learned about these last semester, at least I'm hoping you did. Okay, it includes all the electrons for an element. Now remember what an electron is. It's a negatively charged particle. Okay, our electrons are equal to our number of protons depending on if there's a charge or not. Okay, so let's look at sulfur, for instance. For sulfur, we're going to draw a little example in just a moment. Okay, so remember that the Bohr diagram includes all the electrons, and remember these numbers 2, 8, 8. Okay, oops. We talked about these numbers 2, 8, 8 when we drew orbital diagrams. What this means is that our first electron orbital can hold 2 electrons. Our second can hold 8, and for our sake of our class, our third can also hold 8. Okay, so let me pause this real quick while I go over to my whiteboard so that I can show you how to do this. Alrighty, so here's our whiteboard. I apologize now, I am at home recording this, so I have a janky little whiteboard and it's a janky little setup, so hopefully you can see it okay. So we're looking at sulfur and we're going to be drawing the Bohr diagram for sulfur. Remember first, what is our atomic number of sulfur? Actually, first, what's our atomic symbol of sulfur? Hopefully you remember that it's S. Okay, it's an S. And our atomic number of sulfur is that top number. It's our number of protons, which in this case is 16. Okay, 16 is our atomic number. And just as a review, our atomic number is our number of protons. Now think back to the problem I gave you. Did I give you a charge on sulfur? No, I didn't. So if there's 16 protons, that means we have 16 positives, and we have a 0 charge. How many negatives do I need to get to a 0 charge? I have 16 positives. I will need 16 negatives. So I have 16 negatives, so I have 16 electrons. Okay, that is the first thing we need to figure out. 16 electrons is what we're dealing with. Okay, so I'm going to zoom in over here. Remember that we're dealing with 2, 8, 8. 2 electrons in the first shell, 8 in the second, and 8 in the third. So how you draw an orbital diagram or a Bohr diagram, you're just going to write your symbol and put an orbital around it. So this is our first orbital. Remember back how we learned about the history of the atom? Niels Bohr told us that the electrons are arranged in a planetary model. So they're in these orbits around our atom. Okay, we're dealing with 16 electrons, and our first can hold 2, so we have 2 electrons in our first shell. We now need to draw a second orbital, and now it can hold 8. So we've used 2, so we started with 16, we've used 2, so we need 14 more. So let's put them in. We have 1, 2, 3, 4, 5, 6, 7, 8. Now remember, 8 is how many the second can fill up. So we've used 8, we've filled up our second orbital, but we still haven't gotten to our top number. I want to pause real quick and notice how I filled in the orbits like this, and I paired the electrons. That's important. So make sure when you draw your orbital diagrams, you're drawing them paired. Okay, so we just used 8 more, so 14 minus 8 gives us 6. So we need 6 more electrons, so we need 1 more orbital. 1, 2, 3, 4, 5, 6. This is the Bohr diagram for sulfur. Okay. So you should have already learned how to draw those. We have drawn orbital diagrams before. That should have been a review, I would hope. If that was not a review and you have no idea what I'm talking about, you need to email me immediately after this video, please. Our next new thing we're going to be talking about is Lewis structures. Okay, Lewis diagrams. Lewis diagrams includes the valence shell electrons only. Okay, let's read that again. Notice the Bohr diagrams includes all electrons. The Lewis diagram only includes the valence shell electrons. Now, what's a valence shell? We haven't learned that yet. Okay, a valence electron or a valence shell electron is the electron in the outermost shell. Okay, the electron in the outermost shell. Again, sometimes I might go fast with some of these definitions, so just go ahead and pause the video if you don't have enough time. The electron in the outermost shell. So let's take a look again at our drawing here. Let me make myself big again if it'll let me. I don't know why it won't. There we go. So here's our Bohr diagram of sulfur. I'm going to erase what we have over here and draw our Lewis structure of sulfur. Okay, so our Lewis structure only includes our valence shell electrons. And I just told you a valence shell electron is the electron in the outer shell. Our outer shell on the sulfur is this third layer. Notice how many electrons are in the third layer. 1, 2, 3, 4, 5, 6. So this means that we have 6 valence electrons. So how we would draw our sulfur of a Lewis structure then is only using our 6 valence electrons. So we would have an S, and you're going to go 1, 2, 3, 4, 5, 6. This is a Lewis structure. I'm going to draw it one more time, and I want you to notice where I start putting the dots. 1, 2, 3, 4, 5, 6. Did you notice I started the electrons on the right side of the sulfur? Hold on one moment, I might sneeze. Okay, sorry about that. I started putting the electrons right on the right of the sulfur and went counterclockwise after that. Notice I put 1 on each side and still paired the electrons just like in the Bohr diagram. This is how you draw a Lewis structure. Okay, I do want to give you one more big piece of important information. So you need to know how many valence electrons there are in an atom or of an element. In order to determine those valence electrons, you don't always need to draw the Bohr diagram. There's a trick, and I'm going to show you that trick. Using your periodic table, you can determine how many valence electrons are in an atom. The way you do this is by group number. So notice the periodic table of elements is arranged in these things called groups or columns or periods. So up and down is called a group. Okay, so this is our first group, our second group. Our third group, we actually skip the middle section and go here to boron. It's group 13. So we go to 13 here. Group 4, 5, 6, 7, and 8. So what we're going to be doing is these elements in group 1 are always going to have 1 valence electron. These elements in group 2 are always going to have 2 valence electrons. These are always going to have 3, and so on. 4, 5, 6, 7, and 8 for our noble gases. Okay, there's a little trick for you. If this was confusing for you, please make sure you tune into our supplemental video that I have posted underneath this in case you have more questions. Good luck.